Thank you everyone for joining our webinar. We'll be discussing SBOM accuracy and how to measure up your SCA vendor. My name is Kristen Bianchi. I'm the founder and VP of Sales at Threatrix. Before we get started, I'd like to begin with some housekeeping items. So the webinar length is approximately 30 minutes, which will leave plenty of time for questions. Feel free to enter questions into the Zoom chat and we'll address them at the end of the webinar. So let's start by taking a quick look at the agenda. We have a very technical audience today, but I think it's going to be helpful to first clearly define the SBOM for the context of this webinar. We'll talk briefly about the recent executive order put forth by President Joe Biden and its impact on our industry. We'll talk about all the ingredients that you need for an accurate software bill of materials, which will include some of the sneaky places where open source hides in your projects. John will provide an overview of the SCA vendor ecosystem and, of course, the metrics by which you can measure up the vendor's accuracy. We'll discuss the trends towards real-time SBOMs and how that's shaping our industry. And finally, John will answer your questions at the end. And with that, it's my pleasure to introduce our speaker today, John McDonald, the founder and CEO of Threatrix. John?
Thank you, Kristen. Hello, everyone, and thank you for joining our webinar today. I am very excited about this topic and look forward to sharing my experience as I hope it will help you and your team with a better understanding of accuracy as it relates to the software bill of materials and how to measure up your SCA vendor. Allow me to provide some context on my background, which will help everyone appreciate why this topic is so important to me. I've spent the better part of 20 years as an enterprise software engineer, engaged at a variety of levels in cybersecurity. More relatable to this topic, though, is that over the last 5 years, I've spent considerable time as an engineer as part of the enterprise sales teams for a number of leading cybersecurity companies, including Checkmarx, Shift Left, and WhiteSource. One of my customers was one of the world's largest software companies who was looking to evaluate the capabilities of SCA vendors to assist them with due diligence during their acquisition process. They invited us to perform an analysis of a project they had constructed over the course of a year. This project was pre-vetted by their team, so they knew what licenses existed in the code and could use that data to measure the accuracy of the tools. After we scanned their test project, their team reviewed a report and informed us that we had missed more than 70% of the results. I was mortified, as you would imagine. Needless to say, we didn't win that account. This same vendor was invited back in 2019 with the same results. It was clear to me that we were either incapable or just simply didn't care about producing an accurate SBOM. This experience set me on a journey to understand the challenges of creating a truly accurate software bill of materials and what challenges companies face in this endeavor. So during this webinar, we're going to dive pretty deep, so buckle in. Following several supply chain attacks recently, including the one in the Colonial Pipeline, Kaseya, and SolarWinds breaches, the United States President Joe Biden issued an executive order with the goal of improving the nation's cybersecurity. As part of that initiative, the executive order requires for vendors to U.S. national agencies to provide a software bill of materials. This executive order was intended to provide more transparency in the software supply chain and help consumers, in this case, the national agencies, understand the risks of software provided by the vendors to these agencies. We feel that this is an excellent first step, but there's still a lot of work to be done. Firstly, we feel the SBOM may provide a full sense of security, as more often than not, the SBOM is likely incomplete and filled with results based on patchwork data and guesswork on behalf of the SBOM supplier. How does one go about measuring the accuracy of their software bill of materials? Most of us are using SCA vendors to produce this report. How do we know that it's accurate? First, let's define the SBOM. The NTIA defines it as a complete, formally structured list of components, libraries, and modules that are required to build a given piece of software and supply chain relationships between them. These components can be open source, proprietary, free or paid, and widely available or restricted in access. The SBOM should detail the exact software components utilized in a given product, including any open source components, making it much easier and faster for federal agencies to determine whether they are subject to vulnerability or license with legal implications uncovered in those components. Understanding the software components included in various products will allow organizations to react more quickly when vulnerability and license violations come to light, but only if you can rely on that data to be accurate. SBOMs offer a frictionless sharing between teams and companies will become a core part of software management for critical infrastructures and digital industries for decades to come. We like the SPDX's reason why the SBOM is so important, but today that's really only half the story. While SPDX is simply a medium by which to communicate this information, we'd like to further clarify the importance of the SBOM by adding two valuable descriptors. The first is timely, and the second is verifiably accurate. We'll discuss timely a bit later, but we want to focus right now on verifiably accurate. In open source security and compliance, we've been lulled into a state of accepting whatever information our SCA vendor provides to us as truth. As many of you know, the truth changes with every vendor. Scan your project with Black Duck, and you'll get very different results than you do with White Source. They're both software composition analysis tools, scanning the same project, and in my opinion, should find and report the same composition. So whose truth do you believe? Because we seemingly cannot trust the data from these SCA vendors, we're seeing a number of organizations use more than one SCA tool. We hear that they've selected a vendor because it was the best of the worst, oftentimes choosing one vendor for security and another for license compliance. As the SBOM formats mature, they will support both security and license metadata associated with the components of which your software is constructed. Creating a single SBOM then becomes a challenge for those vendors who've selected separate security and licensing tools. So now let's discuss what's in an SBOM so we can determine if our SCA accuracy is providing the data necessary for holistic, high fidelity bill of materials. Today, there are two common SBOM formats in use. The first is SPDX, which stands for Software Package Data Exchange. And SPDX has recently become an ISO standard. It's currently in version 2.2, which supports only licensed data. However, there's an ongoing initiative to enhance the standard to provide vulnerability data in version 3. It's available for export in two different formats. One is a tag value, which is very similar to a flat file format, and also XML format. CycloneDX was created in 2017 by Steve Springett and is maintained by the OWASP Foundation, who governs it today as a flagship product. It supports both license and vulnerability data and can be exported into XML, JSON, and even protobuf formats. There's a third, somewhat common format called SWID, or Software Identification Tagging. We won't go into the details of SWID here, but I'll post a link in the comments for everyone to see. As you'd imagine, there are also numerous proprietary formats for a software bill of materials employed by nearly every SCA vendor. We won't dive into those formats in this webinar because it's just beyond the scope of this context. The content of each of these popular formats varies by their intended audience. While the CycloneDX format is relatively new, it does not take into account either open source files or snippets of code, which make its intended audience those who don't care about that level of detail for their software bill of materials. CycloneDX is employed by most of the static analysis vendors who also offer an SCA solution, as they often use open source tools provided by OWASP to bring their solutions to market. Checkmarx and Veracode are the exception to this. Checkmarx built their tool mostly in-house, and Veracode bought SourceClear to round out their application security suite. While both SPDX and CycloneDX support a comprehensive bill of materials for package level data, like author, version, and license, and the relationships between those components, only SPDX allows for file and snippet or embedded open source detail within the specification. Excuse me. For this reason, it's the preferred format for organizations seeking the most comprehensive enumeration of license risks. While SPDX is the most common format for licensing data, CycloneDX is used mostly for those looking for licensing and security vulnerability, along with the package data. So as the SBOM becomes an integrated part of vendor, partner, and customer relationships, the trust related to the accuracy of the SBOM will be called into question. After all, what good is a software bill of materials if it can't be trusted to make important decisions about the risk that your organization is being exposed to through your software supply chain? Poor accuracy leads to higher operational costs. These operational costs are killing the budget for many of those who are still using legacy SCA tools. The noise produced by your SCA tool becomes a critical concern when you require a team of open source experts to cleanse the results before making them actionable. We've heard too many stories recently from customers who are frustrated with the operational costs of their legacy tooling. And the SCA industry exists for the purpose of avoiding the risks from lawsuits and security vulnerabilities surrounded by open source software. Donald Trump's platform recently was in hot water recently. The platform he's building is to compete with Twitter, and it was actually built from the Mastodon framework, which is licensed under AGPL 3.0. Tesla recently, you may have heard, open source billions of dollars in intellectual property as part of their autopilot system, because it was found that they had numerous GPL licenses embedded in their code. And just the other day, Vizio was sued by the Free Software Foundation for using parts of the Linux kernel in their embedded software. And while these lawsuits are license related, if your SCA solution fails to support file level and snippet level detection, you can also be exposed to unknown vulnerabilities that went undetected. File level copying of open source is extremely common in many languages, and with those whole files comes vulnerabilities. Now that we have an understanding of what's included in the most popular SBOM formats, how do we determine the accuracy of the data provided? Broadly, we can define accuracy in SCA by the intersections of breadth of detection and fidelity of results. Breadth of detection defines the vendor's ability to detect all of the open source in use by your project, whereas fidelity refers to the ability to associate that open source with its correct origin, license, and vulnerability data, meaning a correct match. Anyone who's used any SCA tool knows what I'm talking about when I say most of the results seem indeterminate. From my personal experience, outside of the data provided by package managers, which includes files and snippet level details, most of the SCA tools are seemingly just guessing at some of the results. When we consider breadth of detection, we have to consider where the open source hides in your projects. As the open source ecosystem has evolved, new tools are constantly being made available to consume open source. It's quite common for developers to use dependency managers to consume whole components when they need only a few lines of code from a given project. With those direct dependencies comes tens or hundreds of additional transitive dependencies. More traditionally, developers will download a component directly into their project. Whole components are delivered in different forms. They can be binary artifacts like a jar file. They can be whole files that represent components like jQuery. Considering jQuery as an example, it can be consumed by many by way of static CDN reference in HTML, or it could also be copied and pasted directly into the HTML into a script tag. Single files or entire projects can be pulled to make use of their source code to solve difficult problems very quickly. These, these are missed or misrepresented by most SCA vendors. Of course, we have partial files. That's files that have been modified by removing the license or modifying parts of the file, parts of the code. And also, if you modify part of that file, it's going to be missed by the file hash. And then, of course, there's snippets of code, which is portions of that file. Lastly, all of the open source is available in more than 400 languages and increasing every day. It's quite common for vendors to support Java, but not Groovy. Developers will often mix these two technologies and will typically be missed by the SCA vendor. While this list is comprehensive, it's not exhaustive. Looking at all the places where open source hides is the first and most important step in creating an accurate bill of materials. This is a visualization of the data from the previous slide. It helps us understand the layering of open source. Those light gray boxes represent the typical breadth of detection for most of the newer SCA solutions and most of the static analysis vendors who've recently brought forth an SCA tool. In order to get our arms around why broad, high fidelity open source detection is so challenging, we have to consider the volume of data necessary to make accurate matches between our available data during the scans of your project and the data that's in the knowledge base. This table illustrates the relative difficulty in matching and why most vendors choose to avoid file and snippet level matching detection. Dependency and package manager data are very easy to correlate to a knowledge base and produce a one-to-one match every time. However, we have to consider the poor coverage from dependency manager only solutions in that they typically only cover about 15 or fewer languages. When we consider file matching, the knowledge base now might return thousands or even millions of potential matches. Consider that there are more than 5 million copies of jQuery in various repositories. Which is the right one? The answer is not as straightforward as you'd imagine, so vendors tend to guess. At the snippet level, there are some snippets that return more than 1 billion matches. The complexity in determining the original author for a group of snippets across potentially billions of matches is a challenge that most SCA vendors choose to avoid. A recent poll by Jari Koivisto, who's a prominent figure in the open source community, shows that 78% of companies want to include snippets in their software bill of materials. So let's consider visually the spectrum of open source detection. If we chart that data, it looks something like this. With broad detection, meaning the ability to find all of the open source in all the places it hides, correlated with fidelity of results. And fidelity is the ratio of signal to noise. So what percentage of the results are true positives versus false negatives, and what percentage were missed altogether. Clearly, as we move up and to the right, the accuracy of detection improves. If we overlay the most popular SCA vendors, weighted by their ability to find vulnerabilities in open source, we can see that SNCC is a clear leader in fidelity, but also falls short in breadth of detection. They're ultimately missing open source. Now let's flip to license-weighted SCA vendors, and clearly Fossil leads in fidelity, but yet again, they lose points for their breadth of detection. Revenera and Black Duck clearly lead the license space with broader detection from Black Duck, but slightly higher fidelity from Revenera. If we're looking for a vendor that provides a holistic SBOM with high fidelity, we're left with few choices, as most vendors were disqualified because they were unable to find all of the open source, and those that have a wider breadth of detection produce a lot of noise, reduce trust, and increase operational costs. Here's a quick reference of the detection and reporting capabilities of the vendors we just spoke about. The gray X's represent supporting these capabilities, but only within the confines of their detection capabilities. This quick reference makes it immediately clear that most SCA vendors are ignoring a lot of open source. Feel free to take a screenshot, but also this webinar is being recorded and will be available after the call. As one would expect, achieving complete breadth of detection and reaching the highest fidelity becomes increasingly difficult as you move up and to the right. This overwhelming challenge to achieve the pinnacle of accuracy dramatically slows time to market, which is why most vendors simply avoid the challenge and stick with package manager only support. So, why are vendors missing so much open source? In the famous words of a CTO of one of the leading SCA vendors, he said, "It's really hard." Most of the newer SCA tools are rushing to market with open source platforms underneath the covers. Determining the correct provenance or origin of these matches is exceedingly challenging for file, let alone snippets of code. Legacy solutions have been working on this problem for more than 20 years, and all they've really achieved is producing results with a lot of noise. More recent tools who've attempted to recreate legacy snippet matching have mostly failed, as they seem to just produce noise faster. As I mentioned earlier, the result is that most companies are forced to buy two tools. So we've covered a lot of ground here very quickly. So let's summarize where your SCA tool should perform well. You should expect that they cover every language in which open source is written. Otherwise, in the wild, you have no idea whether you're missing open source. It's clear that holistic breadth of detection is a foundational requirement for your SCA tool. If they're not looking where the open source lives, how can you expect that data to be in your SBOM? They should be able to accurately report the correct licenses based on the original author of every component, file, and snippet of code. The licenses are derived from the version ranges in which the file or snippet exists. So bear in mind that licenses sometimes change over time. So if your vendor is incapable of providing a version range, they're incapable of accurately determining the correct license for a file or snippet. Your SCA vendor should make your life easier, not more difficult. The data that's housed in your SBOM should reflect a holistic view of the actual open source used in your project and provide a clear signal with little to no noise. As part of the executive order, we've begun to research on what the future may look like for suppliers of software to both consumers and businesses. We're seeing the market as a whole make a broad move towards real-time SBOMs, or SBOMs delivered as part of the software delivery process and intended for the consumers of that software to understand what legal and security implications they may be exposed to as the consumer. This is especially important when we're talking about embedded components, as they're often being distributed directly to autonomous nodes or IoT devices that can be weaponized. We anticipate that as the SBOM process matures, organizations will begin to enforce security and legal risks in terms of contracts. Compliance failures will lead to damages from breach of contract, or may go as far as canceling the contract for numerous infractions. There are several vendors who can produce an SBOM in build time. All of them, however, produce incomplete SBOMs, as they either provide only package manager data or license data derived from files. And in some cases, FOSS-ID and ScanOS snippets. However, the newer vendors just produce noise faster, and this result is not solving our problem. The legacy SCA vendors who support snippet matching for more than 20 years now provide a holistic detection, but they suffer in two critical areas: their ability to produce holistic results in build time, and the noisy results that require a team to clean up before making them actionable. This leads to substantially increased operational costs and increased risk and reduced efficiency. After extensive research, not a single SCA vendor is able to produce a holistic, high-fidelity SBOM in build time, which is exactly why we brought Threatrix to market. 3 years of research and development have culminated into TrueMatch. TrueMatch is the most comprehensive open source detection available, supporting every link in the supply chain and every method by which developers use open source. It was built from the ground up to be massively scalable to hundreds of daily builds across thousands of projects, specifically for Global 2000 customers. We can perform snippet level detection in build time for more than 10 times faster than FOSS-ID and 100 times faster than Black Duck. We support more than 400 languages, with new languages added daily. Most importantly, our results are provably accurate, with proof of provenance associated with every match, with zero noise. We provide results that you can rely on to create real-time SBOMs to comply with Biden's executive order. We're also build server agnostic. You can plug us in anywhere, and we'll find all of the open source and provide the SBOMs you need to remain compliant and stay secure. Finally, once you're comfortable that we've solved the problems plaguing the SCA market, you can automate your license compliance. Threatrix can automatically annotate all of your source code so that your developers don't have to. TrueMatch is one match, the correct match every time. If you'd like more information about how Threatrix can create accurate build time SBOMs for your company, please reach out to us by email or on LinkedIn. And now I'd like to open it up to questions from the audience.
It doesn't look like we have any questions this time. If anyone would like to put any questions into the chat, we'll go ahead and take that. Otherwise, we will go ahead and end it here. All right, we do have a question. Where does a snippet move from an idea to a copy?
That's a great question. So if you talk to attorneys who are sort of the bodies of thought behind that, typically it's around the 30% modification range. So if you harvest a snippet from somewhere and then make approximately 30% changes to that snippet, it'll typically move from what's considered a copy and paste to something that was inspired by the original work. And they've used other resources for that, paintings, books, and sort of the legal precedent is about 30%.
All right, and our next question is, do you have any recommendations for generating an SBOM during the build process?
That's also a great question. We actually have a number of folks who've been talking to you recently who are concerned about that very question, simply because of the Biden executive order. They're looking to build SBOMs during the build process and then be able to deliver them as part of the delivery process for their software. Threatrix is working on a lightweight tool that can be embedded into your build process that will allow you to generate real-time SBOMs that require no interaction to clean up the data, to be able to provide those to your customers, to the consumers of your software, specifically to comply with Biden's executive order. That is forthcoming. We expect that to be available the end of November.
All right, and we have another question. Is there a way for the outside to tell if my software is in violation?
That's a good question. And so, the lawsuits that we've been seeing recently, a lot of them have originated from inside the company. So it's the tattletales or whistleblowers of the developers who are inside the organization. And sometimes it's apparent from the outside. So if you have, for example, the Vizio situation, anyone can sort of reverse engineer a Vizio television and say the Linux kernel is embedded in there and they're violating the GPL license. So it really depends on your distribution mechanism for your software. Obviously, if it's internal and no one has access to it, it's an API, it becomes more challenging. But in many cases, especially in the IoT and embedded world, where you're delivering your software to some product, those are relatively easily reverse engineered to understand sort of the broad level components that are involved in that embedded software, and ultimately if it violates those licenses that's licensed under.
All right, I don't see any more questions. John, did you want to add any more details?
I don't have any other details. I just want to thank everyone for joining our webinar today. We are tremendously excited about the executive order. We think it brings a lot of light to an area that needs light, exposing the cybersecurity risks and certainly the sharing of information between organizations. And we look forward to working with with the industry to help bring that to fruition. So thank you for joining our webinar today. And again, if you have any questions, any further questions, please feel free to reach out to us by email or connect with us on LinkedIn.
Thanks, everyone.
Thank
Have
you,
a great
everyone.
day.